The symbol for a JK flip-flop is shown here. It's basically you draw a rectangle and you write JK, and you know that it's a JK flip-flop. I've also drawn the truth table for a JK flip-flop here, and we evaluated this truth table in the previous video, right? Now, take note of what happens in this case, especially in this particular state, right? In this particular state where q and q bar are kind of changing values, right? If j and k are 1 1, what happens to the output? The output becomes the opposite of what it was before. So in the next state, it's going to take the next value and the next value. So if the clock remains 1 for some time, then what will happen to the output? So let's say q and q bar were 0 and 1 to start off with. So as long as the clock remains 1 and j and k are 1, the output becomes from, let's say it starts with 0 and 1. Then in the next state, it becomes 1 and 0, and then it becomes 0 and 1, and then it becomes 1 and 0, and then it becomes 0 and 1. And depending on where you stop, where you stop your clock, right, make it 0, your output could either be 1 0 or 0 1. Okay. I hope you see that. So basically, what I'm saying is that because your output is continuously changing states in this particular condition, there are oscillations at the output as long as the clock is 1, and you don't know what is the output that you will get uh, uh, when you apply j equal to 1 and k equal to 1, right? And the reason why you are having this problem is because your inputs can influence your outputs for all the time the clock is 1. So as long as the clock is 1, this oscillation from 1 to 0 to 1 to 0 to 1 is going to continue, and whenever the clock becomes 0, that will stop. Okay. Now, is there a better way of doing this? Of doing this, and is there a way in which we can say, well, whenever j is 1 and k is 1, can I trigger my flip-flop so that I get opposite of what I previously had instead of continuous oscillations? Does that make sense? Let's see what the solution could be in the next video.